In this lecture, we continue to review algebra. We will practice some problems involving the algebra of exponents and the algebra of polynomials. Here are some problems from an old quiz. Simplify this expression. Let's rewrite the numerator, the cube root of x to the 6th, as x squared since, and this is the meaning of cube root, x squared cubed is x to the 6th, so the cube root of x to the 6th should be x squared. In the same way, we can rewrite the square root of x squared as x, since this is merely the meaning of the square root. This gives a new expression. Our fraction is now the same as x squared divided by x, and by our laws of exponents, this should just be x. Let's simplify this expression. We'll begin by simplifying the numerator. X to the 6th to the 1/3 is, by our rules of exponents, the same as x squared. And x squared on top times x to the minus 2 on top is x squared divided by x squared is the same as 1. So the numerator now simplifies to 1, and so we have 1 over x to the 4th, or x to the minus 4. So we've simplified this problem. Let's simplify this expression. 2x cubed plus x squared divided by x to the 4th. We'll factor the numerator, 2x cubed plus x squared. We'll pull out an x squared, noting that 2x cubed is 2x times x squared, and x squared is 1 times x squared, so that when we pull out the x squared, we're left with 2x plus 1. So we've rewritten the numerator this way. Notice also that x squared divided by x to the 4th is 1 over x squared. So once we factor out that x squared in the numerator, we will simplify x squared over x to the 4th as 1 over x squared. And so our answer is 2x plus 1 over x squared. Once we learn the algebra abbreviation called exponentiation, we can often use polynomial arithmetic, factoring polynomial, to simplify an expression. For example, here's a complicated fraction involving fractions in both the numerator and denominator. But dividing by 1 over x squared in the denominator, that's the same as multiplying by x squared over 1. And x squared over x to the 4th is the same as 1 over x squared. So when I take this complicated expression and I multiply the old numerator by x squared over 1, it simplifies to 2x cubed plus x squared divided by x squared. We can factor the numerator, factoring out an x squared. Now our x squares on top and bottom will cancel, and so we end up with just 2x plus 1. Here are some other simplification problems involving factoring. Recall that a minus b times a plus b is a squared minus b squared, and so we know how to factor a difference of squares. So we can simplify this expression. Recognize that the numerator x squared minus 9 is x squared minus 3 squared. It's a difference of squares. And so I can replace x squared minus 9 on top as x minus 3 times x plus 3. And now I can cancel out the x plus 3's, top and bottom. In other words, we'll divide the top and bottom by x plus 3, and we're left with x minus 3. Second example, let's simplify x to the 4th minus 9 over x squared plus 3. Again, use the same pattern as before, recognizing a difference of squares. X to the 4th minus 9, the numerator, is really x squared minus 3 times x squared plus 3, and now I can simplify this expression and get x squared minus 3. This is so easy, a caveman can do it. One more. Let's simplify x minus 9 over the square root of x plus 3. There are two ways to do this. Again, we could do this as a difference of squares if we're really willing to be a little bit creative. Think of x as the square of the square root of x. So x minus 9 in the numerator is the square root of x squared minus 3 squared. So I can factor that numerator in this way, and then cancel like terms and get the square root of x minus 3. Or maybe you were taught at some time to multiply by the conjugate here. If faced with x minus 9 over this expression with a square root, we can multiply top and bottom by the square root of x minus 3 and simplify the denominator and then cancel terms. The denominator becomes x minus 9, and now we have x minus 9 in top and bottom, and so our answer again is the square root of x minus 3. To succeed in calculus, we need comfort with these algebra techniques, so practice these techniques throughout the semester so that you can indeed be comfortable with your algebra.